2002 National Electrical Code, Chapter 3, addresses wiring methods and materials. Article 300 focuses on wiring methods, including Section 300.3, which specifically covers color coding. Section 300.3b states that conductors of the same circuit, including grounding conductors, shall be identified by color, except as permitted in 300.3b and through b4. Section 300.3b addresses conductors and conduits. It specifies that conductors of different systems in the same conduit shall be distinguished by color. Furthermore, conductors of the same system in the same conduit shall be distinguished by color where necessary for identification. Section 300.3b2 pertains to conductors and cable trays, stating that conductors of different systems in the same cable tray shall be distinguished by color. Additionally, conductors of the same system in the same cable tray shall be distinguished by color where necessary for identification. Section 300.3b3 outlines exceptions to the color coding rule. Firstly, conductors in raceways or cables of 6 feet or less in length are not required to be color coded. Secondly, conductors for starting and stopping motors with the voltages between 6 and 600 volts are also exempt. Thirdly, field wiring of control equipment does not require color coding. Fourthly, power and lighting conductors for auxiliary gutters are excluded from this requirement. Section 300.3c specifically addresses grounding conductors, stating that these shall be identified by a continuous green color or by a green color with one or more yellow stripes. Based on the 2002 NEC, conductors of the same circuit in the same conduit must be distinguished by color where it is necessary for identification. Since the wiring in your PVC pipes involves different circuits, color coding is essential to differentiate them. The claim that color coding is unnecessary due to the wires being in PVC and outdoors is not supported by the NEC. The code does not include exceptions for outdoor installations or conduits lacking knockouts. Therefore, adhering to the color coding requirements is vital for ensuring electrical safety and compliance with the NEC standards. Understanding these regulations is crucial for proper installation and maintenance of electrical systems, particularly in generator wiring scenarios. Ignoring the color coding rules can lead to confusion, potential hazards, and code violations. Always consult the latest edition of the NEC and seek guidance from qualified electrical professionals to ensure compliance with all applicable regulations. The NEC aims to standardize electrical installations, making them safer and more reliable for everyone. Therefore, adherence to these guidelines is of utmost importance in all electrical work. Consider the example of a multi-wire branch circuit in a residential setting. This circuit typically consists of 2 hot wires, a neutral wire, and a grounding wire. To comply with the NEC, the hot wires must be different colors such as black and red, the neutral wire must be white or gray, and the grounding wire must be green or bare. This color coding allows electricians to easily identify the different conductors and avoid accidental connections that could cause short circuits or electrical shocks. In a commercial or industrial setting, the color coding requirements may be even more stringent, especially when dealing with multiple voltage systems. For instance, a facility might have 480/277 volt, 208/120 volt, and 24 volt control circuits. Each voltage system must have its own unique color code to prevent confusion and ensure that electricians can safely work on the electrical system. The NEC provides specific guidelines for color coding different voltage systems, and it is important to follow these guidelines carefully. Furthermore, the NEC also addresses the use of color tape or other markings to identify conductors that have been re-identified. For example, if an electrician needs to use a black wire as a neutral in a particular situation, they must mark both ends of the wire with white tape to indicate that it is being used as a neutral. This helps to prevent confusion and ensures that other electricians working on the system in the future will be aware of the change. In addition to color coding, the NEC also requires that conductors be labeled with their voltage and current ratings. This information is typically printed on the insulation of the wire, and it helps electricians to select the appropriate conductors for a particular application. The NEC also specifies the types of insulation that are allowed for different applications, and it is important to use the correct type of insulation to ensure that the wiring system is safe and reliable. When working with electrical systems, it is always important to follow the NEC guidelines and to take appropriate safety precautions. Electricity can be dangerous, and it is essential to have a thorough understanding of the electrical code and to use proper safety equipment. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work for you. The information provided here is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician before starting any electrical project. Remember that the NEC is constantly evolving, and it is important to stay up to date with the latest changes. The NEC is revised every 3 years, and it is essential to use the most current edition of the code to ensure that your electrical work is compliant. You can purchase the NEC from various sources, including the National Fire Protection Association NFPA website and local bookstores. You can also find online resources that provide information about the NEC, such as the NFPA website and various electrical industry websites. In addition to the NEC, there may be local electrical codes that apply to your area. These local codes may be more stringent than the NEC, and it is important to be aware of them. You can typically find information about local electrical codes on your city or county government website. When working on a generator installation, it is particularly important to pay attention to the grounding requirements. The NEC requires that generators be properly grounded to prevent electrical shock hazards. The grounding requirements for generators can be complex, and it is important to consult with a qualified electrician to ensure that the generator is properly grounded. The NEC also addresses the use of transfer switches for generator installations. A transfer switch allows you to safely switch between utility power and generator power. The NEC specifies the types of transfer switches that are allowed for different applications, and it is important to use the correct type of transfer switch. The NEC also requires that transfer switches be installed in a manner that prevents backfeeding of power onto the utility grid. Backfeeding can be dangerous and can damage electrical equipment. In addition to the technical requirements, the NEC also includes administrative requirements. For example, the NEC requires that electrical work be inspected by a qualified electrical inspector. The inspector will review the electrical work to ensure that it complies with the NEC and local electrical codes. It is important to obtain the necessary permits before starting any electrical work. The permit process ensures that the electrical work will be inspected and that it meets the required safety standards. The NEC is a comprehensive document that covers all aspects of electrical installations. It is essential to have a thorough understanding of the NEC to ensure that your electrical work is safe and compliant. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work for you. Remember to always prioritize safety when working with electricity. Use proper safety equipment, follow the NEC guidelines, and consult with a qualified electrician if you have any questions. By following these guidelines, you can ensure that your electrical installations are safe and reliable. The use of color coding is not just limited to the conductors themselves. The NEC also addresses the color coding of terminals and other electrical components. For example, the NEC requires that the neutral terminal in a receptacle be identified by a white or silver color. This helps to prevent accidental connections and ensures that the receptacle is properly wired. The NEC also addresses the color coding of overcurrent protection devices, such as circuit breakers and fuses. The color of the handle or body of the overcurrent protection device indicates its ampere rating. This allows electricians to quickly identify the correct overcurrent protection device for a particular circuit. The NEC provides a table of color codes for overcurrent protection devices, and it is important to follow these guidelines carefully. In addition to the color coding requirements, the NEC also includes requirements for the labeling of electrical equipment. The NEC requires that electrical equipment be labeled with its voltage, current, and power ratings. This information helps electricians to select the appropriate equipment for a particular application and to ensure that the equipment is properly installed. The NEC also requires that electrical equipment be labeled with its listing information. The listing mark indicates that the equipment has been tested and certified by a recognized testing laboratory, such as Underwriters Laboratories UL. The listing mark provides assurance that the equipment meets the required safety standards. The NEC also addresses the use of flexible cords and cables. Flexible cords and cables are used to connect portable electrical equipment to a power source. The NEC specifies the types of flexible cords and cables that are allowed for different applications, and it is important to use the correct type of flexible cord or cable. The NEC also requires that flexible cords and cables be protected from damage. Flexible cords and cables should not be run through doorways or windows, and they should not be subjected to excessive strain. The NEC also addresses the use of extension cords. Extension cords are used to extend the reach of a power cord. The NEC specifies the types of extension cords that are allowed for different applications, and it is important to use the correct type of extension cord. The NEC also requires that extension cords be used safely. Extension cords should not be overloaded, and they should not be used as a permanent wiring solution. The NEC also addresses the use of surge protective devices (SPD). SPD are used to protect electrical equipment from voltage surges. Voltage surges can be caused by lightning strikes, power outages, or other electrical disturbances. The NEC specifies the types of SPD that are allowed for different applications, and it is important to use the correct type of SPD. The NEC also requires that SPD be properly installed. SPD should be installed as close as possible to the equipment that they are protecting. In addition to the technical requirements, the NEC also includes requirements for the maintenance of electrical systems. The NEC requires that electrical systems be inspected and maintained on a regular basis. This helps to ensure that the electrical system is safe and reliable. The NEC also requires that electrical equipment be properly grounded. Grounding provides a path for fault current to flow back to the source, which helps to protect people from electrical shock hazards. The NEC specifies the methods that are allowed for grounding electrical equipment, and it is important to follow these guidelines carefully.